confusion. But today I'm going to talk about all the concepts once again. That is surface tension, surface energy, bubbles, drops, how to find the excess pressure, as well as we'll end with capillarity. Everything will be done today. So let us start with the first topic, which is surface tension. So give the heading as surface tension. If you're lighting for the first time, give the heading as surface tension. Generally, when you hear the word tension in physics, up to now from mechanics knowledge, you think tension is a force, isn't it? Because tension is a force, that's how we have learned till now in physics. But this chapter you will realize that surface tension is not a force. Understand that first. It is not a force. Then what is it? Mathematically, surface tension is force per unit length. It is force per unit length. I'll talk about this now. Theoretically, what is the meaning of it? So its unit will be what? Newton per meter. Which other quantity has the same unit? Newton per meter. Force is Newton per meter. Very good. Which force you are learning, man? It is Newton per meter square. Which other physical quantity has the same unit, Newton per meter? Anybody knows? You have learned this quantity in 2 chapters in physics. One chapter is work, energy and power. One chapter some of you would have learned in SSM school. Torque. Torque is Newton meter. This is Newton per meter. Anybody who can tell? Shoaib Ahmed, any idea? If you are hearing me. What, when you sitting and searching now? By the time you search, I will tell the answer. No idea. Forgot. Recently you have learned spring constant. K, F by X. F is Newton, X is meter, Newton per meter. You learnt in work, energy and power also. Elastic potential and stored. U is equal to half kx square. There also I told K is Newton per meter. So the SI unit of surface tension resembles that of spring constant. Anyhow, this question has come couple of times in competitive examination. That Newton per meter thing. Okay, coming back. So what is the meaning of the word surface tension? Let us understand that first. Okay. So to understand surface tension, let me first tell you in a very basic layman's word that suppose I am having a container like this. There is a vessel. Come fast, man. Close the door. Come fast. So suppose I am having a vessel. Settle down fast, please. Yeah. In the vessel, I am having water. Okay. There is a vessel. Inside the vessel, I have water. Imagine if I am having a needle. Needle is made up of steel, isn't it? That needle I am putting in the water. Whether the needle will float or it will sink. Float. I'll bring a container now, needle out. If you make it to float, no, I'll give you 500 rupees today. So I said the answer. Huh? Why it will float, by the way? What is the principle of flotation or sinking? Tell me. How do you decide whether you go inside the water, you will float or you will sink?
Sink.
Why?
Because we have we have larger mass than compared to
Larger mass than water. Larger density than mass.
water.
Density of U is more than density of water. That's why you will sink. Okay, I agree. I agree. So density of steel is less than density of water.
Not, but
It is.
in the needle it is less than 1.
Oh, is it so? It means that if you are having steel 1 gram, steel 2 gram, steel 1 kg, you will have different density. Very good. Density is not depending upon mass, man. Density is mass per unit volume. If volume will change, mass will also change. Density will remain constant. Density is constant for all particular material, man. Density of one substance is more than the other, it will sink. Karthikeyan, last warning, man. Video is found to be off. You will not be there in the meeting. Don't make me tension. Please. Already I am in surface tension now. But coming back, please pay attention. Please pay attention. So if you have needle which is made up of steel, its density is obviously more than density of water. It should sink. Technically. Okay? But there are ways by which you can make it to float. What is the way?
Maybe
Oh. Instead of keeping like this, you keep like this, it will not think you're thinking.
Sir,
I'll give a chance to you. Yeah, tell me, Srinidhi. That's what is the way? This is the water level. Shall I keep it like this? Shall I keep it like this? Or shall I keep it at some angle? What is the way of keeping? Some angle. Never try. Yeah.
so actually, there somewhere I've seen that they will keep the needle on a paper and.
That is the way. That is the way. Correct. What you should do, take the needle, place the needle on a paper. Put that paper in the water.
Paper will go down and.
Paper will go down not immediately. It will get wet fully. After needle gets fully, paper gets fully wet, it goes down, leaving the needle on the surface. Why? Density not changed. How paper helped? Let us understand the concept of this. Okay? Because of surface tension. Surface tension is a property by which, I'll give the definition. First listen. Surface tension is a property by which the top surface of the liquid behaves like a stretched membrane, elastic stretched membrane. Why it is stretching itself? To reduce the surface area. Why it wants to reduce surface area, we will learn now. Okay? So, let me assume that there is a liquid, water in this container. I am talking about two different molecules. One molecule which is here, another molecule which is here. Okay? So, you should know that any molecule will have a sphere of influence. What is the meaning of sphere of influence? You know that any, whether solid, liquid or gaseous state, there is an intermolecular force. There is an intermolecular force of attraction, right? You know what about intermolecular force of attraction? Intermolecular force of attraction is every molecule inside a matter will have a force of attraction. Give me a second, sorry. Yes, ma'am. Yes, ma'am. You can continue the class, ma'am. You have the number of Pandupriya, ma'am? Okay, I'll ask her to call and speak to the parents. I'll think. You call this for getting students for today's investigators. Okay, you can call once again and check with the liquid. What are the students have come? Okay, I was waiting for them to start. Yeah, yes. You check, check with her how many have come. Write the names. Those who are not, you can call. Sorry. Yeah. So please let us continue. So I was talking about something called as sphere of influence. Some of you may know, some of you may not know about it. Let us learn what is that. So I was saying any state of matter is having intermolecular force of attraction, which is the force of attraction between all the molecules. So do you think that if there are many molecules like this, there are so many molecules in a state, this particular molecule is having a range up to which it can attract the nearby molecules? Are you aware about this? Don't think that this can attract this molecule. No. If it has a range of this much only, then whatever molecules come in this range only will get attracted. That is what is called as molecular range. So molecular range is the sphere, we call it as sphere of influence. It is the area under which whatever molecules are present, they will get attracted towards the molecule. So every molecule will have its own sphere of influence that is attracted by other molecules. So if a molecule is here, well inside the liquid, then it is going to attract all the other molecules towards itself, right? It's going to attract. But if you see this molecule, if I draw a sphere of influence of this, if I draw a sphere of influence for this molecule, then you will realize that the net downward force is more than upward force. In this case, if you see the equal amount of downward force and equal amount of upward force is there. So net force becomes 0 and the molecule is stable. But the molecule present in the top layer, technically it is called a surface film. If you hear the word surface film, it means topmost layer of liquid where the molecules have more downward force compared to the other molecules present below, well below the liquid. So these molecules, I'm talking about all the molecules present above, what is the problem with them? They have a sphere of influence in such a way that the downward force is more than the upward force. Since downward force is more, it is trying to be pulled downwards, right? And remember that if the force is more, its potential energy is more. And potential energy is more, it is unstable. Are you aware about this? Because suppose there is a pen here, its potential energy suppose x. If I make it to come here, its potential energy increased, but it became more unstable now. It can fail anytime, right? So if whenever the potential energy increases of anything, it also brings it with the less stability. So this molecules present in the topmost layer, since they have higher potential energy, so they have less stability. They are not stable. Now what they want to do? To want to become more stable, they should have less energy. To have less energy, they should have less area. And what they do, they try to stretch themselves to have least molecules and least surface area, so that they are having better stability than the previous condition. So understand, the surface tension concept itself comes from the stability of the surface film molecules. I'm sorry. Molecules present well inside the liquid, they have no problem because they are already stable. Why they are stable? Net upward force, net downward force is same, net force is 0. They need not to worry about its stability. But the molecules present in surface film, what is surface film? Topmost molecular layer. They are having more downward force than upward force, increasing their potential energy. And since their potential energy is more, they are less stable. To gain stability, they want to reduce this energy, and to reduce the energy, they reduce their area. That's why they behave like a elastic stretched membrane. This phenomena or this concept is only called as surface tension. If in the examination, if the question comes like, write the molecular theory of surface tension. Whatever I taught you now is called as molecular theory of surface tension. So if in the examination they will ask for 3 marks, write in detail about the molecular theory of surface tension. Whatever I spoke now, you should write in words. I'll give the notes for it. Start writing. Write that. The molecules well inside the liquid, the molecules well inside the liquid, the molecules well inside the liquid have equal amount of upward and downward force, have equal amount of upward and downward force, making the net force to be 0, making the net force to be 0, making the net force to be 0. Whereas the molecules present in the surface film, in bracket you can write topmost layer of the liquid, After writing surface film in bracket you can write topmost layer of the liquid. There is more downward force than the upward force. There is more downward force than the upward force. Than the upward force. This increases the potential energy of such molecules. This increases the potential energy of such molecules. This increases the potential energy of such molecules and making them unstable. Making them unstable. To increase their stability, to increase their stability, to increase their stability, the molecules in the surface film, the molecules in the surface film tries to have less surface area, tries to have less surface area to reduce the energy. Therefore, forming an elastic stretched membrane, an elastic stretched membrane in the top layer of liquids. In the top layer of liquids. This property is known as surface tension. This property of liquids is known as surface tension. This property of liquids is known as surface tension. You can also change the paragraph and write one more statement. Surface tension also depends upon the temperature. Surface tension also depends upon the temperature. Surface tension also depends upon the temperature. With an increase in temperature, there is a reduction in surface tension. With an increase in temperature, there is reduction in surface tension. So in the exam, if they ask you what happens if there are two liquids in two different temperatures, whether they will have same surface tension or different, it will be different. The liquid having higher temperature will have less surface tension, lower temperature will have more surface tension. So this concept is called as surface tension. Change the paragraph and also write the definition of surface energy. Surface energy. Right? The extra energy. The extra energy possessed by the molecules of surface film. The molecules of surface film. The extra energy possessed by the molecules of surface film is known as surface energy. Is known as surface energy. Mathematically, it is defined as work done per unit change in surface area. Work done per unit change in surface area. Work done per unit change in surface area. Surface energy is work done per unit change in surface area. Now, what is work done? Unit I am asking. Joules. And what is area unit? Meter square. So what will be SI unit of surface energy? Joules per meter square. Now, think for a while, you will realize something. Joule means force into displacement, energy, isn't it? One second. Hello. Okay, I'm in class now. I'll speak to you. You just try from your side. Not possible, just leave it. No problem. I'll speak to you. Sorry. So I was talking about this work done. So work done means force into displacement. So force is Newton, displacement is meter, divided by meter square. This gets cancelled. What do we get? Once again, same as surface tension. So write one statement. Numerically, surface energy is always equal to surface tension. So instead of using surface energy, you can always replace it with surface tension, because surface tension and surface energy are same. Though they have different formula, force per unit length, work done by changing surface area, but they will end up in the same quantity. Okay. Theoretically, it is looking a little complicated also, but questions are very simple from here. I think I remember solving some questions for that batch, that is 8 to 9 p.m. batch from this concept. I mean, I'm talking about the offline batch. I have solved some questions, right? No? Surprise. Then where I have solved? Okay, take one question. Take one question. To understand it better, take one question. Everybody please take the question. A mercury drop of radius 1 centimeter, a mercury drop of radius 1 centimeter, a mercury drop of radius 1 centimeter is broken into 10 lakh droplets of equal size. 10 lakh droplets of equal size. Calculate the work done if surface tension of mercury is 32 into 10 to the power minus 2 Newton per meter. Solve this. Try solving this question. Let me know if you get any answer. Pratosh, if you are hearing me, your camera is not working, I guess. Check your camera, please. So this kind of question, since this is the first question of today, I will just help you in this question. Next, you can solve by yourself. This kind of question whenever comes, see what is happening. They are saying that there is a drop of mercury. Anything they told about radius, anything? 1 centimeter. Oh, 1 centimeter radius is beginning to 10 lakh droplets. Okay. So 1 centimeter radius mercury drop is there. It is breaking into, I cannot draw 10 lakh, 10 to the power 6 droplets. Am I right? 10 lakh means only no. Hey, 5 is 1 lakh. You put 5, so I should write 5. Huh? 10 lakh means 6 zeros. 5 zeros is 1 lakh. So 10 to the power 6 small drops, but radius not given. Okay. Now what they say? They are saying what is the work done for this change. If one big drop is breaking into 10 lakh small drops, how much work is done in this? So you know the formula. In the previous page I gave the formula of work done. Work done will become equal to surface tension multiplied by change in surface area. Surface tension is given to you. If you are able to find change in surface area, you will find the work done. Because you know that surface energy or surface tension is equal to work done by change in what? Surface area, isn't it? So here the work done will become equal to surface tension times change in surface area. I hope you are understanding this. Now surface tension is known, which is how much? 32 times 10 to the power minus 2. What is not known? Change in surface area. How to find that? This area also you can find. Surface area you can find is 4 into pi into r square. R is how much? 10 to the power minus 2 the whole square. Am I right? 1 centimeter is 10 to the power minus 2 meter, no? What is thought? Pi r square. I am not taking. Surface area, yeah? Sphere. Am I right? Okay. 10 to the power 6 droplets. The area will be 10 to the power 6 times of 4 pi some different r square. I don't know what is the value of this r. Am I right? I am finding the area of each droplet. So one drop will have 4 pi r square. 10 to the power 6 droplets will have 4 pi r square times 10 to the power 6. Now the question is, how do you find this r value not given? We can find, you know how? They will have equal size. This is, they are having equal size, but what remains same in both? One quantity, huh? Total radius. Volume. In 10 you studied surface area and volume, no? That only is used here. So volume before it breaks and volume after it breaks remains same. Area will change, radius will change, but volume will be same. If 1 liter of water you are throwing, this water will be 1 liter only, no? It will not become 2 liter or 1.5 liter or 0.5 liter. It will remain 1 liter only. Same way, what is the volume of this drop? 4 by 3 pi r cube. What is the volume of this drop? 10 to the power 6 times of 4 by 3 pi r cube. Do you agree with me? So 4 by 3 pi gets cancelled, isn't it? Then I want to find r cube. So r will become cube root of this will become r, and 10 to the power 6 cube root will become 10 to the power 2 if I am right, isn't it? Am I right? How it came, you understood, no? I said this down, put cube root. Understood, no? So r is 1 centimeter or 10 to the power minus 2 meter. So 10 to the power minus 2 by 10 to the power 2 will become equal to 10 to the power minus 4 meter. You got a value of r? Over now. This will become, this area we know. Now this area will be 10 to the power 6 times of 4 into pi into what is r? 10 to the power minus 4 square. Subtract this area minus this area. You will get the change in surface area. Multiply by this value, you will get the value of work. Got it? Simple question. That's how numericals are coming from this topic. One more numerical to give you some confidence. Then we'll go to the next concept. Shall I give the numerical? Calculate the work done. This question you can solve, but take another question also. Calculate the work done. Calculate the work done in blowing a soap bubble. In blowing a soap bubble. In blowing a soap bubble from radius 2 centimeter to 3 centimeter. From radius 2 centimeter to 3 centimeter. Surface tension is given as 30 dyne per centimeter. Surface tension they gave for this question as 30 dyne. They have given in CGS unit. Okay. So find the answer in ergs itself. Work done means you can find in ergs, CGS itself. Don't try to see. I think this same question I have solved earlier. Is it? This one I remember I have solved in. That's why I told I have solved in one batch this concept. So same question, I think I have solved it earlier also. What?
30 hertz.
30 hertz. Man, which chapter are you learning, man?
30 Newton.
Hey, work done is in Newton. Work done is in Newton.
Joules.
30 joule.
Yes, sir.
You found the area and everything. You are in which class, man? Huh? Tambi, Eva, today is test, you know or not? 3-hour test. Are you there in the group or not? 2 days back, they sent message, you're not minded, eh? Go.
Which test is it?
Go in opposite room and ask. Okay? Which test?
Change in surface area.
Will be? What you did? What you multiplied? Oh, very good. Changing from 2 to 3, eh? Huh?
Yes, sir.
So 3 minus 2 is 1. God save you. How, man? If here radius is becoming from 3 to 4, the area also will also change from 3 to 4 only. Area will be pi r square, no, man? Or 4 pi r square in this spherical case. So 4 into pi into
2 square. 2 square minus 4.
2 square. That will give you the change in area. So work done will become equal to surface tension is given as 39 per centimeter into change in area. So as you are thinking 4 pi, what is r square? I'll take common. So it will become 3 square minus 2 square. Am I right? When you solve this, you will get some answer in ergs, which will be a wrong answer. When you solve this, everything used correctly, put the units also correctly, but your answer will be wrong. Why? Why, man? Answer will be wrong. Loudly. No. No, man. I am okay with CGS unit. It will have two surface. It's soap bubble. I hope you have seen soap bubble. Played with slow bubble, no? At one point of your time. Now also you are playing. Taking the thing and blowing air. Bubble comes out. How many surface it will have? Why I say two surface? Because see, inside air, soap, air. Yeah, I have taught this, I remember. Numericals, same numericals I have talked. Check your note. Same value, same question. If it is a water drop, only one surface. Because here water, outside air. If it is air bubble, what is air bubble? Inside the water, you have that Sprite bubbles, no? Outside water. So one surface. So remember that drops, air bubbles will have one surface. So bubbles will have two surfaces. So whatever answer you are getting should be multiplied by 2. Then only the answer will be correct. Got it? Simple question, multiply and get the answer, and multiply by 2 to get the correct value. Anybody has doubt in this? I hope it is simple and clear. Okay, if yes, the next concept is about meniscus and angle of contact. Shall I change the page? Next concept is angle of contact and meniscus. So I hope you know what is the meaning of adhesive force and cohesive force. This I have taught, I remember, in both the batches. What is the meaning of adhesive force and cohesive force? What are those? Adhesive means?
Strong bonds between molecules or
Okay, what is cohesion? Weak bond. Very good. No. If
the force of attraction between the particles of same substance.
yes, what is that? Cohesion or adhesion?
Cohesion.
Cohesion. Adhesion is different molecules. If you are writing by chalk on the board, it is adhesion between chalk and the board. If you are sticking paper with another paper, it is adhesion because you are putting some Fevicol and sticking adhesion. Cohesion is shown by mercury. It won't stick on the wall itself. If you have mercury throw on the wall, it won't wet it. Why it won't wet it? It won't stick in the wall itself. It has too much strong cohesion. But throw water, it will stick on the wall. It will make it wet because it sticks on the wall. there the adhesive force is more than cohesive force. So there are three possibilities, that is adhesive force being more than cohesive force, adhesive force being less than cohesive force, and adhesive force being equal to cohesive force. What are these three conditions? Pay attention here. If adhesive force is more than cohesive force, then we will have a meniscus like this. That is, the liquid is trying to wet the wall, it's sticking to the wall. If adhesive force is less than cohesive force, we will have a meniscus like this, where liquid is not trying to touch the wall, stick to the wall. If they both are equal, it will be like this. In the previous lecture, when I taught this topic, I also told you which combinations will give. This is called as concave meniscus. This is called as convex meniscus. This is called as plane meniscus. For example, if you are having a glass and water, it will give you concave meniscus. But if you are having a silver glass and distilled water, it will give you plane meniscus. If you have mercury in a glass, it will have convex meniscus. Different combinations of materials will give different meniscuses. It can be concave meniscus, can be convex meniscus, can be plane meniscus. Now, meniscus helps you in understanding the meaning of angle of contact. What is angle of contact, you know? It is the angle, I'll give time for writing, please pay attention. It is the angle between tangent drawn to a liquid surface with the solid surface. With the solid surface. For example, here, tangent drawn and this angle is angle of contact. Here, this is the angle of contact. So what is angle of contact? Write it down. Angle of contact. It is the angle made between. It is the angle made between. Angle made between the tangent drawn on a liquid surface. The tangent drawn on a liquid surface with the solid surface. With the solid surface. With the solid surface. So in concave meniscus, angle of contact is acute, isn't it? In convex meniscus, angle of contact is obtuse. And in plane meniscus, angle of contact is right angle, which is 90 degree, isn't it? So angle of contact is important to understand capillarity. And to understand angle of contact, you must know about the adhesive and cohesive force, because that only decides whether it is going to be concave meniscus or convex meniscus. Okay. Now coming back to, before I go to capillary, last topic of this chapter, I would like to talk to you about water drops and soap bubbles. Shall I give that heading? Can I change the page? Yeah. Then give the heading as excess pressure inside soap bubble. After we derive for soap bubble, we can extend this to water drop also or air bubble also. Okay, concept remains the same. So I am taking soap bubble, which is having two surfaces. Whatever answer I get, I will divide by 2 to get for water drop or air bubble. Okay, now please pay attention. Have you ever seen that if you are using the soap bubble for playing or whatever? So you take and when you blow air, bubble comes out. Whether bubble remains forever or it bursts after some time. It bursts. Need not to burst after going and touching something. It will go and burst after a few seconds. Leave it. Why it bursts? Because the topic is excess pressure. Very good. Actually, if you cannot notice it very from naked eye because it's very micro phenomena. But what happens when the bubble is coming out of that stick? Bubble slowly expands, and then it bursts. Because it won't be able to expand further. It will burst. Why is it expanding? Because there is a pressure acting on this bubble from inside. Are you getting my point or not? This property is creating some excess pressure inside the bubble, which is trying to make it bigger. Before, at a point where it cannot further become bigger, it will blast. It will burst. So this pressure only we are trying to find what is the value of this excess pressure inside the soap bubble. Now let me assume that radius of this bubble is r. Let me take it as it has a radius of r, capital R I am taking. Okay. Since there is a pressure acting on this bubble, I'll give time for writing, Thambi. Pay attention. It is expanding. After few seconds, the area will become little bigger. That is, the r will become little bigger. Let me assume this extra increase in r is dr. So previously, its radius was r. After some time, radius became r plus dr. R dash I can write r plus dr. Okay. So now I have the original area. Then I have the final area. Subtract both, I will get increase in surface area. If I multiply by surface tension, I will get work done. Am I right? So what I am trying to find now is work done to increase the surface area. This is what I am trying to find. Increase the surface area. How do I find that? Multiplying surface tension with the increase in area. Do you understand? I hope you are understanding what I am trying to say. Because that is the formula of surface tension, no? How I am writing this, you are understanding or not? From the previous concept. You are there in the class, Jagdish? Problem is there, ask me. Okay. So, increase in area. Initial, what is the area? 4 pi. Actually, first I will write the increased area because I want to subtract both. 4 pi r plus dr the whole square minus 4 pi r square. Do you agree with me? But it won't give me the correct result. Once again, the same reason. Two surfaces. One is outside surface, one is inside. Some of you may argue with me, but outside will have bigger radius than inside. No. It is not that big solid surface here. It is soap bubble. Thickness will be nanometers or Armstrongs. So yes, true. As you're thinking, it has little more radius, but we cannot, assume it here. So I am just multiplying with 2. So I am just writing here 2. Why am I multiplied by 2? Multiplied by 2. Multiplied by 2 due to 2 surfaces. Understanding? Now solve this. This will become how much? 2t. I'll take 4 pi also common outside. 4 pi. What it will become? R square plus dr square plus 2r dr minus 4 pi is outside. So r square. Isn't it? R square gets cancelled. What is dr? Small increase in the radius. It's a small quantity. It will be in some minus 10 to the power minus 3 millimeter and all. Squaring it will make it much smaller. We negotiate it, we neglect it. Yeah, we can neglect it. So dr square can negotiate, can be neglected since it is very small. So it will become 2t 4 pi 2r dr. Multiply everything, no? 4 plus 4 into 2 is out. 8 into 2 is 16 pi r drt. Understood? This is work done. Work done is also equal to force into displacement. Do you agree? And force is also equal to pressure into area. Pressure is P here. Area is, initial area is 4 pi r square here. And change in the length is, that is, displacement is dr here. Are you getting what I have done now? Yeah, I'll do that. But this step is clear to you. How to make it go there here? It will make it bigger. Let it be okay. No problem. At least something. So 4p into 4 pi r square dr is equal to 16 pi r drt. Any problem in this? I hope no. Dr gets cancelled. 4 pi, it will make it 4 times. R square and r will get cancelled. So we are going to get the value of excess pressure as 4T by R. Any problem in this? So excess pressure inside a soap bubble is how much? 4T by R. You should tell me what will be for water drops? Water drop or air bubble. How much will be that?
Divide by 2.
Divide by 2. How much is that?
2T by R.
Excess pressure will become equal to 2T by R. Okay. So for soap bubble, the excess pressure is 4P by R. For water drop and air bubble, it is 2T by R. If it is clear to you, please copy it. Make it fast, please. Done? Everybody? Then let us learn about capillarity. Shall we? We'll talk about capillarity now. So before I talk about capillarity, I would like to ask you, what is the meaning of the word capillary? Yeah, capillary means hair only in Latin. It's a Latin word, it means hair. Capillary means hair. Hair means very thin. So this concept has come from something called as thin tubes. Have you ever wondered that even for tall trees, we are giving water in the root, but the water is reaching where? The topmost part of the tree. It may be 70-80 meters also. There are trees in the world which are 70-80 meters tall. In Africa you will go, rainforest you go in the Amazon. You have 100 meters trees also, 100 meters long tree. And those trees are receiving the water in the topmost point, but we don't want to go and put the water there. Put water in the root itself. Have you ever wondered how the water is traveling from root to the top? There is no motor there, there is no pump there. So how is it able to travel there? Only by the action of capillarity. So capillarity, right definition, it is the phenomena by which the liquids rise or fall. It is a phenomena by which liquids rise or fall inside a capillary tube. Inside a capillary tube. In bracket you can write about capillary tube, you write. It's a very narrow tube. Very narrow tube. So understand that you can see the phenomena of capillarity only in narrow tubes. You cannot see it in the thicker tubes. Suppose I am having a pipe and I am expecting to see capillarity, I cannot see there. But imagine you are having the refill of a pen. It is very thin. Inside that capillarity can be felt. But if you want to see in the pen itself, you cannot see because it is thick enough for not supporting capillarity. So capillarity can be seen only in very thin tubes. The thin tubes have a name. It is called as capillary tube. Now, while defining capillarity, I gave two things: rise or fall. So there are two possibilities. If you have, suppose, a vessel, inside there is some liquid, and if I keep a tube here, capillary tube, you know what will happen? The liquid will rise inside. There is a possibility that you have some liquid, and if you keep inside the tube, the liquid will fall inside. That is also possible. You know this? Which case you know? In the case of mercury. Because the cohesive force is more than the adhesive force, there will be a fall. This is called as capillary fall. And if there is water, which is having more adhesive force than cohesive force, then we will have a capillary rise. That's why while defining capillarity, I told the rise or fall of a liquid inside the narrow capillary tube. Are you getting my point? So which liquids will rise? The liquids whose adhesive force will be more than the cohesive force. Which liquid will fall? Which has cohesive force more than the adhesive force. Okay, it is rising. You also know about meniscus. So now what I am going to do, here meniscus will be like concave meniscus. I am zooming it and drawing it here to derive the height formula that is called as ascents formula. Now what we are going to derive is called as ascents formula. I am taking the help of that diagram and I am zooming it and showing you. Okay. So don't think it is a very broad tube. Just to show you big, I am drawing a broad tube. I am just zooming it. Okay. And on the top surface, you have this kind of concave meniscus, right? I hope you, is it a call or an alarm? Okay, you are keeping alarm for getting up at 7 p.m. Okay, okay. So ascents formula, we are going to find the rise, capillary rise. Now please pay attention, please. So I am drawing like this height is the capillary rise H. Okay, now please pay attention. If you see, the more narrow the tube is, the more curve it will be. Basically, you know what is that? It is like a sphere. Like a sphere. You know one thing, the more narrow you take, the more curve will come. Basically trying to form a spherical surface above. It is a spherical surface above. Just now we learned about excess pressure. This part will have an excess pressure inside. And this excess pressure is only pulling the liquid towards itself. That's why the liquid is rising above. Why is it rising above? Due to the presence of excess pressure in the topmost area, which is almost a spherical area. Not exactly spherical because the pipe is little broad. If you make it, so imagine if I make it very small, it will become like this kind of, right? Give me a second, sorry. Yes, ma'am. Yes, ma'am. No, ma'am. You can make one because how many are 22 are there? No? Yeah, you can. Yeah, that's why you can make one. Okay. Sorry, coming back. So now this excess pressure only is pulling the liquid above. That's what I was trying to say. Now what is excess pressure here? 2T by R or 4T by R? 2T by R. Why 2T by R? Because only one surface, liquid and the air above it. Okay. Now, this circle, if I write 2t by r, what r is this? This r, isn't it? That's what is r. It is of the bubble or spherical surface. And this r, if I am drawing a line here, this r is the radius of the tube. Am I right? Understand diagram well. The small r that I have drawn is the radius of the tube. Capital R is the radius of the circle, which circle means the spherical part of the tube. Okay. You know that this angle is angle of contact theta, concave acute angle because concave meniscus. And I told you what is angle of contact, angle made by the tangent drawn to the liquid surface with the solid surface. If you see carefully, you will realize if this is theta, this will be 90 minus theta. It is 90 degree, no? Theta, 90 minus theta. 90 minus theta, this will become theta. Because this is 90 degree once again, tangent to a circle is perpendicular, radius and the tangent are perpendicular, right? This angle becomes theta. Okay. Now in this triangle, I want to find what is cos theta. What will be your answer? R by R. So I can write capital R is equal to R by cos theta. Do you agree? Do you agree? Substituting it there, I got the value of pressure as 2T. So pressure is equal to 2T by R. I am writing R, and above what goes? Any problem in this? Okay. Now, first draw this diagram. Make it fast. Second class has to start. Copy it fast. Written? One thing you'll understand now. So can I finish it? Shrestha, 2 minutes, but pay attention here. So we know that pressure is also equal to rho GH, isn't it? So rho GH is equal to 2T cos theta by R. From here you get the height by Essend's formula, 2T cos theta by R rho G. So the Essend's formula says that height of the capillary rise is 2T cos theta by R rho G. Now please pay attention. You will realize that this height depends upon certain things. It depends upon the surface tension of the liquid. It depends upon the angle of contact. It depends upon the radius of the tube. It depends upon the density of the liquid inside. And obviously the G is actually same in a particular place. Now see, this gives two understanding. One thing is why there is a capillary fall. Because theta is the angle of contact. For mercury, we have a convex meniscus. Convex meniscus will make angle of contact as obtuse, more than 90 degree. Cos theta, which is more than 90, will be negative. So it will be a negative height. Negative height means it is a fall. Second thing that you are understanding is R is there, no? Why we should take narrow tubes? Because if you don't take narrow tubes, height will be not raising much. So H and R are inversely proportional. The lesser the radius, the more is the height. That's why the roots of trees will be in micrometer size. Above don't see. I'm talking about the part where the water takes above. It will be in micrometer, nanometer size tube. That's why they're able to transport the water. The more tall the tree is, the more thinner its root is. Because it has to take more height. Understood? Second thing is also depends upon density. So liquids which have lesser density will go more taller. And liquids which have, like suppose you have honey and water, which will have more capillary rise? Obviously water. Because water has lesser density, it will have more height. And more density will have less height. Got it? Copy this up fast. So 1 second. So that's all for this chapter. I think whatever you asked yesterday, I've done it now, right? I proved, no, just now by dimensions. By dimensions you can prove. I wrote Newton meter, you can find dimension of both. That is, it will become ml t power minus 2 for both. Because ml, not ml, mt power minus 2. So L will get cancelled by down. So find dimension of surface tension, dimension of surface energy, proof both are same. Okay. So we will wind off now because I have to leave for another class. And we will meet again in the next session. Okay, if something else is there which you want to ask me, you can message me. Maybe tomorrow also we can have some class. Tomorrow is actually officially leave for academy. But if somebody has some doubt, you can ask me. I can arrange a class for you, or maybe I can arrange an online class for you, whatever. Okay. So those who have copied it can start moving. Bye bye. Take care. Good night.